Good morning, students. So today we are going to discuss the toppers JEE NEET foundation. So the class 9th gravitation. So gravitation is the subject, which comes under the physics. Gravitation, no universe. No gravitation, no universe. So gravitation is very important to exist the universe. So to understand the gravitation, we have some conceptual understanding questions. The first question, the first question if you take, according to Kepler's law of orbits, so the option A, all the planets move in elliptical orbits with the sun situated at one of the foci of an ellipse. Option B, all planets move in elliptical orbits with the earth situated at one of the foci of an ellipse. Option C, planets move in parabolic path with the earth situated at one of the foci of ellipse. All planets move in parabolic orbits with sun situated at one of the foci of parabola. Among all these things, out of 4 options, Kepler's law, Kepler derived 3 laws: law of orbits, law of areas, law of periods. Law of orbits, sun is located at one of the foci of an ellipse. Let us take, this is the ellipse, so this is the sun. Sun is located at one of the foci of ellipse, and planets revolves around the sun. This is law of orbits. So according to this, all planets move in elliptical orbits. And with the sun is situated at one of the foci of an ellipse. So option A is the correct answer. The remaining options, it is not situated, earth is not situated at one of the foci, and planets, not in parabolic path. So that's why all 3 options B, C, D are wrong. A is the only correct answer. So this is about first question. Then we'll go to the next question. The second question is, that is gravitation. So gravitation, the second question, the direction of universal gravitational force between particles of masses m1 and m2 towards dash. There is a gravitational force between 2 particles. Let us say m1, this is the m1 mass of the particle, m2 is the mass of another particle. So how the force is going to be directed, the direction of acceleration, the direction of gravitational force, how it is going to be there. When there are 2 masses are separated by certain distance, according to Newton's law of gravitation, the force acts between the 2 masses. There is a force acts on the m1 due to m2. There is a force acts on m2 on m1. So this is the forces. If you observe here, there are 2 different masses. So the force of mass 1 acts on 2. The force of mass 2 acts on 1. Both are opposite in direction. So it means that, in the given options, option A directed towards the center of the earth. So wrong answer. So directed towards mass m1 only, wrong answer. Directed towards mass m2 only, wrong answer. The right option is, the directed towards m2 on m1, directed towards m1 on m2. There are 2 different forces. So 2 equal forces but acts in opposite direction. So that's why option D is the correct answer for this question. So the next question, third one, the value of G at a particular point is 9.8 meters per second square. The value of G at a particular point is 9.8 meters per second square. So suppose the earth suddenly shrinks to the uniformly half of its present size. See, suddenly earth shrinks without losing any mass, then the value of g at the same point will be what? See, it means that the mass does not change. So only we are saying that earth is suddenly shrinks. Okay. See, whenever earth shrinks, the g depends upon the mass. G is equal to gm by r square. So without changing its mass, so there is a change in the, there is a sudden shrinkage. So assuming the distance point from that does not shrink, distance is also not changed, mass is also not changed. So it means that the g value also does not change. Whatever the g value 9.8 meters per second square, the same value will be there, okay, at any point when earth suddenly shrinks also, because here mass is not going to be changed, radius is also not going to be changing. That's why. So the g value is only 9.8 meters per second square. 9.8 meters per second square. So that is about the question number 3. So now see fourth question. If the mass of the body is on the, the mass of the body is m on the earth surface, then the mass of the same body on the moon surface is what? See here, if you observe carefully, this is the, on the earth and this is on the moon. Here on the earth the mass of the body is m. What will be the mass of the body on the moon? See, mass does not change. Mass remains the same at any place in the universe. That's why, the mass on the moon is also, the mass of the body on the moon also will be, so same m will be there. It is not going to change any mass. So that's why capital M is the right answer. M by 6 and 0, none of the above, all these are wrong answers. So option B is the correct answer. So we'll go to the next question. The next question is, the fifth one, if the density of the earth increases by 4 times and its radius becomes half, what is our weight will be? See, here you should understand, first of all, the density changes by 4 times. Let us assume that, d1 is the density of the earth. So d2 is nothing but the density which is changed to 4 times. So 4 times of d, 4d. See, the radius of the earth is r. Then radius becomes half. R2 becomes r by 2. See, we know the formula. So G is equal to gm by r square. The capital G small g relation. So capital G is gravitational constant, capital M is mass of the earth. Mass of the earth can be written as, capital G into volume of the earth into, density of the earth. Let us take density D upon r square. So if you write G into volume of the earth, it is 4 by 3 pi r cube. 4 by 3 pi r cube into density is D upon r square. So it means, capital G into 4 by 3 pi r into density. This is the formula, G into 4 by 3 pi into, it means that small g is directly proportional to r into d, because the remaining all constants. Capital G is constant, 4 by 3 pi is also constant. G is directly proportional to rd. So now we'll try to take, here, G1 upon G2 equal to, what we can write, rd means, r1 upon r2 into d1 upon d2, you can write. So r1 upon r2, r1 is given as, here small r1 I have taken, that's why small r1, small r2. So r1 is r and r by 2, r2 is r by 2 into d1, d1 is nothing but d, upon 4d. G is directly proportional to rd, so that's why you have to take like that. So now if you take it as the G1 is nothing but earth. So G1 is earth. So if you take it as, see the calculation here. So G1 upon G2 is nothing but, okay, so here again I am writing that G1 upon G2 is nothing but R upon R by 2 into, see density. Density is nothing but, see density is increased by 4 times. So D upon 4D. So if you simplify this, DD get cancelled, R by RR get cancelled. So it is nothing but 2 by 4 will come. So 2 1 ja, 2 2 ja. So G2 equal to, okay, so 2 G1 will come. See, weight depends upon acceleration due to gravity. Weight depends upon acceleration due to gravity. Hence, weight also W2 is nothing but, okay, see twice of the W on the earth. What is our weight? Will be B doubled. In the given options, if you take, the option C is B doubled. It is not 4 times, it is not remains B doubled and B half. So, remains same. Okay, see that is also, it is not supposed to be remains same is also not correct. So, only B doubled is the C. Here there is a printing mistake. Okay, please. So, ignore that. So, this is about the, see B doubled is the correct answer. So, next question. See, the question is 6th one. The force of gravity is least at dash. See, the force of gravity. See, at equator, poles, point between equator and poles, none of these. The gravity, force of gravity will be, see, at the poles, see, gravity will not be least because force always, okay, see at equator, see the G value is minimum at the equator, so the force of gravity is also minimum at the equator. Okay, so the force of gravity is minimum at the equator. So force of gravity is nothing but weight. So it is depends upon, see F is equal to mg here. See the G value at the poles, G value at the poles, it is 9 okay, see 83 will be there, G value at the poles. Okay, see this is the pole and this is the equator. At the poles G value will be maximum and G value at equator will be 9.78. At equator will be minimum. That's why the force of gravity is least at equator. Equator is the correct answer. The remaining options are wrong. So this is about question number 6. So yeah, question number 7. What will be the profitable to purchase 1 kg of sugar by spring balance? Option A, poles at equator at 45 degrees latitude, at 40 degrees latitude. See, this is the poles and this one is the equator. See, 40 degrees latitude and 45 degrees latitude. If you observe carefully, where will be the profitable to purchase 1 kg sugar? For example, you are purchasing 1 kg sugar. So, see 1 kg sugar, where will be the G value will be maximum? So, G value will be maximum at the poles, G value will be minimum at the equator. So, it depends upon latitude, G value also depends upon latitude. So, that is G lambda equal to G minus omega square R. So, cos square R lambda. Okay, so see, of course, this is the formula. We are not going to discuss this. See, here G value, okay, see, will be at poles will be the maximum. So, poles will be the maximum. So, G value will be maximum means you will get, see, the sugar will be, you are getting less compared to, at equator will be, you will be having the G value will be minimum. So, when you purchase, okay, see 1 kg of sugar, at equator it will be profitable for you. So more sugar you are going to get at equator compared to, okay, so poles, because G value is maximum at the poles. G value is at maximum at the poles. So that's why, okay, so the gravitational force will be more. So then definitely you will get less sugar. At equator, G value will be minimum. That's why you will get more sugar. That is the simple logic. So next question. Yeah. See the next question, if you take, that is ninth question. The weight of an astronaut in an artificial satellite revolving around the earth. See, artificial satellites will be, this is the astronaut. So there are two people will be there, astronaut and cosmonauts. Astronauts usually other than Russia. So those are space people, those space who are going to space. Okay, so astronauts, other countries they will, okay, so cosmonauts normally the space, the people are, okay, so Russians, if they are sent to the space, they are called as cosmonauts. If other countries are sent to the space, then they are calling it as astronauts. That's it. That is the only difference here. See, the weight of astronaut in the artificial satellite. See, when a person is there in the satellite, so satellite is revolving, okay, around the earth. So in some circular orbits are, okay, so whenever satellite is revolving, is there any, so we are fuel is used in that. So definitely, see, due to the inertia of motion only satellite will be revolving around the earth. So the weight will be zero. The weight will be zero. The weight of a person, okay, weight of astronaut in the satellite will be, not only astronaut, any object which is there, it is going to be zero. So because due to inertia of motion only it will be revolving. Okay, so that is, so one important point you have to remember. So this is about 9th question. Then 10th question. See, during the journey from the earth to the moon and back, the greatest energy required from the spaceship, the rockets to overcome. See, whenever you want to do, okay, see, like moon traveling or something, we cannot do it, but usually scientists, recently America also trying to send person to the moon. So what they will first take priority? The priorities are these only. The earth gravity should be take off. If you don't cross this earth gravity, okay, the earth gravity should be take off, then only you can go into the space. That is the first thing you have to remember. Any space rockets to overcome this, so earth gravity should be taken off, then only possible. The moon gravity, we are no way connected with that, because earth gravity is always pulling the body to the earth. That should be taken off, then automatically you can travel, okay, so to other celestial bodies like moon or any other objects, any okay, so galaxies in the universe you can travel, but this should be there. First point you have to remember that. So that's why option A is correct. The remaining options, moon's gravity at lunar takeoff, not correct. The point where the pulse of the earth, so this is also not correct. Actually the answer is earth gravity should be takeoff. So that is the question number, okay, see, I think 9. These are all the 10th question, I think. So these are the conceptual questions which are there in gravitation 9th class. Then the next is single correct answer type questions. In the single correct answer type questions, we have the first question. A satellite in the elliptical orbit. See, there is a apollon, okay, of 6r and a perihelion is 2r. So the radius of the earth is 6400 kilometers. The rate, okay, so, and find the eccentricity of the orbit. See, to understand this, first of all, okay, see, yeah, you should know what is meant by apollon and what is meant by perihelion. So, for example, this is the, see, just understand here, ellipse. So, ellipse will have two focus. Okay, see, there are two focus will be there. Let us say this is the first focus and this is second focus. So, there are two focus will be there for the ellipse. See, let us take, this is the point O and let us take this point is A and this is the sun. Sun is located at one of the foci of the ellipse. So, this is the, see, from the sun, see, from the sun, so the closest see this orbit, planet orbit is this. Let us take, okay, so SA is the closest distance. So the closest distance we will call it as a perigee. We will call it as a perigee. So, and the largest distance, not close, which is SB, that is okay, see apogee. We will call it as a apogee. So these are the two things we have to remember. Closest is perihelion, the point on the path we will call perihelion, and so here aphelion. So these are the two things, 6R and 2R. See 6R and 2R, there it is, we have to find out here the eccentricity. What is eccentricity? Eccentricity is nothing but, okay, see eccentricity is the constant in the ellipse. Okay, see, to find out eccentricity, see OS by OA. This is the formula for eccentricity. Eccentricity is nothing but OS. O is the center of the ellipse to the sun. OS upon OA. This is the constant. Okay, see what we will call eccentricity. OS by OA. So OS is equal to, what I can write it is, okay, see E into OA. E into OA. So if you try to find out this, so we can find the values perihelion and epsilon. Okay, so SA is equal to, see SA is equal to, what I can write, SA is nothing but, so OA minus OS. OA minus OS. See OA minus OS is nothing but EOA we can write. EOA. So OA into 1 minus E you can write. OA into 1 minus E you can write. Similarly, SB if you try it, okay, see if you try to find out SB, SB is also you are going to get OB into 1 plus E you are going to get. So now SA and SB are given. SA and SB are given. So that is nothing but SA upon SB or SB upon SA. If you take SB is given here 6R, so SA is given 2R, so that equal to here 1 plus E upon 1 minus E. So that is 1 plus E upon 1 minus E is equal to 3. So if you take it off, so 1 plus E upon 1 minus E equal to 3. So then 1 plus E equal to 3 minus 3E. So you are going to get here 4E is equal to 2. Then E is equal to 2 by 4. It is 1 by 2. So the option 1 by 2 is the correct answer. Option 1 by 2. Eccentricity 1 by 2 you are going to get like this. See, this is about the, see, question number 1 in the single correct answer type. So the next question. See, this is the simple way. See, explanation is given for that question. So A plus 1 into E, A into 1 minus E, what I explained, the same thing, 6R by, so 3, E value eccentricity is 1 by 2. I hope you understand. So the next question, a Saturn is 29.95 times of the Earth year. How far is the Saturn of the Sun? Earth is away from that. See, now Saturn year is given, the Saturn year. The Saturn, you know that is a planet which is revolving around the Sun. So Saturn is revolving around the Sun. Here the comparison is given. See, the comparison is actually, so that TS value when you compare with the Earth, that is 29.5 times of TE. Now the radius of the Saturn, radius of orbit of the Saturn will be how many times, see, radius of the Earth. So of course here options are not given. Okay, see, you can take the, see, simple way, answer is this. The distance from the Earth, the distance of the Earth from the Sun, it is 150 million kilometers, 1.5 into 10 power 11 meters. Time period of the Earth is TE. Time period of the Saturn is, okay, see, TS, then 29.5 times of TE. So now if you try to use the Kepler's third law. What is Kepler's third law? T square is directly proportional to R cube. So from that you can write Ts square upon Te square is equal to Rs cube upon Re cube. So if you substitute the values, see the value of Re is 1.5 into 10 power 11 meters. 1.5 into 10 power 11 meters. So from that you are going to get the value of radius of the orbit of a Saturn is 14.32 into 10 power 11 meters. So 14.32 if you convert 1.43 into 10 power 12 meters. This calculation only little difficult because the value to find 29.5, okay, see power of 2 by 3, it is not so easy. We have to use logarithms, otherwise we should know the value of that, okay, by other means. Then only we can find these type of questions. Of course such questions will be asked, but they provided this value in the paper. Definitely they have to provide the value, then only we can solve such problems in JEE Mains or Advanced. So the next question, see the question number 13, that is the mean distance of the mass of the sun 1.524 times of the earth from the sun. So then find the number of years required to make one revolution about the sun. See the distance is given here. Again also this is also similar model problem. The calculation is little difficult. See the mean distance, if you observe here 1.88, 18 years, 18.8, 180. The formula is same here. See the planets revolves around that. See if you observe that here also the T square is directly proportional to R cube. Similar formula. So T directly proportional to R power 3 by 2. Here T of the mass of the planet upon T upon the T earth is nothing but, see 1.54 times is given, okay, whole power 3 by 2. This value also very difficult to find. Unless and until they give in the question paper, we cannot solve such problems. So directly, of course, by using calculator and other things we can do it, but it is difficult for the children to do this type of okay calculation. So but as a, see that is T mass is 1.88 times of earth years. You can find like this. This is the way of solving this question. So the next question, a satellite in the elliptical orbit about the earth, the radius is 6400 kilometers. The perigee has an altitude of 1100 kilometers. At apogee the altitude is 6100 kilometers. So then the major axis of the orbit, see of course here if you observe carefully, see here this is the elliptical orbit. So there is a perigee and there is a apogee, okay. So these are the two things. Perigee is the closest distance, apogee is the, see, largest distance from the sun. So now if you try to find out, see apogee distance if you try to find out and perigee distance if you find out, from the center of the earth you have to find out. So apogee distance becomes, see the apogee distance, let us say this point is O, okay, see this is A, OA is equal to, so the radius of the earth should be added, that is 6400 kilometers plus the distance, altitude is given. So for the, see perigee altitude how much it is given, perigee altitude is 1100, so the 1100 is given, okay. See that becomes how much it is, 7500 kilometers, 7500 kilometers. See this is OA. Similarly if you try to take OB, so OB also if you try to find out, again from the radius of the center of that 6400 plus, okay, see the altitude at it, see it is given 4100. If you try to find out 6400 plus 4100, so that is so 10,500 kilometers. So now the total distance, okay, the length of the major axis for the ellipse, AB is the major axis. So then AB can be find out, okay, OA plus OB, OA plus OB if you try to find out. So 10,500 plus 7,500, that is nothing but 18,000 kilometers. 18,000 kilometers. In the given option, 18,000 kilometers is the only D is the correct answer. The remaining all three options are wrong. See, this is the simple way you can solve this problem. So this is about question number 14. And so if you observe that the question number 14 explanation, by the property of the ellipse major axis, you can find like this: 2a 4100 plus 6400. 6400 is the radius of the earth plus 1100, 18,000 kilometers. You can solve in this way, very simple way. Thank you. Yeah, thank you very much. Thank you for listening this class. So I hope you understand everything. So I am ending the session. Thank you. Clear.